Welcome to Science Documentary for Sleep Channel. Tonight, we're going to explore the quiet journey toward the last star in the universe. At first, that sounds impossible, because nothing around you feels as though it is ending. Perhaps there is a small lamp glowing nearby. Perhaps moonlight rests softly against a window. Perhaps another house, somewhere beyond the trees, still carries a warm light behind its curtains. Everything feels ordinary, familiar, steady, yet almost every source of light surrounding you shares one secret. Every one of them is slowly running out of time. The remarkable part is not that stars eventually die. The remarkable part is that they shine at all. By the end of tonight, you will understand why the final star in existence may survive longer than imagination itself. You will travel farther than any spacecraft could ever reach. You will witness entire galaxies fade into silence. And you will discover why the end of time is not an explosion, but something infinitely quieter. For now, there is only one simple observation. Darkness does not rush toward the light. The light slowly surrenders itself. That difference changes everything. Imagine reaching toward the switch beside your bed. One gentle movement. The room becomes dark. Your eyes need a few moments to adjust. Shapes soften. Corners disappear. Familiar objects drift into shadow until only faint outlines remain. To your senses, darkness arrived instantly. Nature rarely behaves that way. The universe prefers patience. Stars never simply switch off. Instead, they spend millions, billions, or even trillions of years quietly transforming themselves from within. Every second they lose a little more of the fuel that allowed them to shine in the first place. The process is almost impossibly slow, too slow for any single human life to notice. Yet every heartbeat that has ever echoed inside your chest has happened during that slow, cosmic countdown. That realization carries an unexpected comfort. The stars are not eternal guardians standing above history. They are travelers, just like us. Only their journeys unfold across oceans of time instead of decades. Take another familiar example. Imagine placing an ice cube onto a wooden table. You know exactly what will happen. It begins to melt, not because something dramatic occurs, not because anyone hears a sound, simply because warmth quietly continues its invisible work. If you leave the room, you return to find only a small pool of water. Nothing spectacular happened. Everything happened. Stars live according to a similar rhythm. Deep inside every shining sun, gravity continually presses inward. Pressure becomes heat. Heat becomes nuclear fusion. Fusion transforms hydrogen into helium. That transformation releases enormous amounts of energy. Some of that energy finally escapes into space as light. The sunlight warming your face tomorrow morning began its journey inside our sun hundreds of thousands of years ago. It wandered through dense layers of glowing plasma before finally escaping into open space. Then it traveled another 8 minutes before reaching Earth. Light itself is patient. Perhaps that explains why starlight feels strangely peaceful. Every beam has already completed an extraordinary voyage before quietly arriving in your eyes. Tonight, countless ancient photons are doing exactly that. Some began traveling before your grandparents were born. Others departed their stars before humans built the pyramids. A few left long before mammals even existed. The night sky is not a picture of the present. It is a collection of carefully preserved memories. Every direction becomes another chapter. Every star becomes another clock. Some clocks tick quickly. Massive blue stars burn with astonishing brilliance. Yet brilliance demands payment. They consume their nuclear fuel with extraordinary speed. Many survive only millions of years. On cosmic calendars, that resembles striking a match. Beautiful, powerful, brief. Smaller stars behave differently. They burn gently, carefully, patiently. Their quieter light allows them to survive for billions or even trillions of years. The universe often rewards restraint. That lesson appears surprisingly familiar. Many things around us follow similar patterns. A candle burning fiercely disappears sooner. A slow campfire warms the night for hours. A hurried sprint leaves us breathless. a calm walk carries us farther. Nature quietly repeats the same idea across astonishingly different scales. From campfires, to stars, to galaxies, the similarities invite a quiet kind of wonder, not because human life resembles the cosmos, but because the same simple laws shape both. Gravity never grows tired. Energy never forgets its path. Time never pauses. Everything changes. Only the speed changes. This realization introduces our first true obstacle. If stars inevitably fade, what happens after enough time passes? At first, the answer seems comforting. Surely new stars simply replace old ones. That is exactly what has happened throughout much of cosmic history. Massive clouds of hydrogen collapse. Gravity gathers the gas. Pressure rises. A newborn star ignites. Its light begins another story. Meanwhile, older stars quietly disappear. The balance continues. The night sky remains full. For billions of years, the universe has maintained this magnificent cycle. Birth, life, silence, then birth again. Yet every cycle slowly spends something precious. Hydrogen, the simplest element, the first great fuel, the original inheritance left behind after the Big Bang. Imagine owning an enormous library. Each year you remove one book. At first, nothing seems different. Shelves remain crowded. Thousands still remain, but no new books ever arrive. Eventually, the missing spaces become noticeable. Then entire shelves stand empty. Finally, only one volume remains. The universe owns an unimaginably vast library. Its books are stars. Its pages are hydrogen. Its librarian is time. Time never loses count. Even now, every galaxy quietly withdraws another tiny portion from its ancient collection. No observer notices. No alarm sounds. The silence itself becomes part of the process. This is where the scale suddenly expands beyond ordinary imagination. The Earth is about 4.5 billion years old. Our Sun is nearly the same age. Human civilization occupies only the final fraction of that story. Written history resembles the final grain of sand resting upon an endless shoreline, yet even billions of years barely introduce the larger narrative. Ahead lie trillions, then quadrillions, then numbers requiring entire pages merely to write them. Our language begins to struggle. Our intuition quietly surrenders. And perhaps that is perfectly natural. Human minds evolved beneath forests, beside rivers, across grasslands. We learned to estimate days, seasons, generations, not epochs stretching longer than every mountain ever raised upon Earth. Still, there is something deeply calming about attempting the journey anyway, not because we can fully understand it, but because wonder asks only for curiosity, never perfection. Tonight, we have taken only the first step. We switched off a lamp. We watched darkness arrive. Then we discovered that darkness is rarely the active force. Instead, light slowly grows tired. That simple reversal changes the meaning of the entire universe. Because if every star is quietly spending its ancient inheritance, another question naturally appears. How many stars remain before the great cosmic library begins to empty faster than it can refill? The answer leads us toward a sky already growing older. A sky whose quiet transformation has already begun. One that patiently waits above us every single night. Almost unnoticed, almost unchanged, almost. The first thing you notice each evening is rarely a star. It is usually the fading blue above your neighborhood. The trees become silhouettes. Birds grow quieter. Windows begin to glow. Only then do the brightest stars quietly appear, one after another, as though someone were gently uncovering an ancient painting hidden behind daylight. The sky feels timeless. It seems unchanged from childhood, yet that comforting impression hides an astonishing truth. The night above your head is already growing older. Imagine opening a family photo album. The faces remain frozen inside each photograph. Grandparents smile forever. Children never grow taller. Every image preserves a single moment that can never change again. Looking at the night sky is remarkably similar. Every star sends you a photograph made from light. Some photographs are only a few years old. Others began their journey before the Roman Empire existed. Many started traveling long before humans learned agriculture. You never see the universe exactly as it is. You see countless carefully preserved memories arriving together. Light travels incredibly fast, nearly 300,000 kilometers every second, fast enough to circle Earth more than 7 times in a single heartbeat. Even at that impossible speed, the universe remains so vast that distance becomes measured in years instead of miles. A light year is simply the distance light travels during 1 year. About 6 trillion miles. Numbers like these quickly become difficult to picture. So imagine walking across the United States. Now imagine repeating that walk billions upon billions of times. Only then do you begin approaching the true scale hidden between neighboring stars. This immense distance creates an unexpected effect. Every glance upward becomes an act of quiet archaeology. Astronomers often say that telescopes are time machines. Not because they change time, because they collect older and older light. Looking farther away also means looking farther into the past. A galaxy 1 billion light-years distant appears as it existed 1 billion years ago. A more distant galaxy reveals an even younger universe. Space and time become woven together like threads inside the same fabric. Traveling across one almost always means traveling through the other. That idea feels strange at first. Yet, nature offers gentle reminders. Listen to thunder after lightning. The flash arrives first. The sound follows later. The storm happened only once. Your senses simply receive different pieces at different moments. The universe behaves similarly, except the delay is measured not in seconds, but in centuries, millennia, or billions of years. Every star becomes a message traveling across an immeasurable ocean of darkness. Some of those messages come from stars that no longer exist. A brilliant giant may have exploded thousands of years ago. Its final light still continues toward Earth, somewhere along its long journey. It quietly crosses empty space. It passes drifting clouds of gas, forgotten planets, lonely asteroids. Eventually, it reaches your eyes, carrying news from an event already finished. You experience a quiet echo. The star has vanished. Its light has not. This realization softens our understanding of the sky. We often imagine the heavens as permanent architecture, fixed lights decorating an endless ceiling. In reality, the cosmos is alive with slow change. Stars ignite, others collapse, galaxies collide, black holes grow, clouds of hydrogen slowly disappear. Nothing remains completely still. The pace is simply far beyond ordinary human experience. Consider an old forest. Visit it once each year. Every visit feels familiar. The same paths, the same river, the same towering trees. Yet after 50 years, everything has changed. Some giants have fallen. New saplings have appeared. Moss covers forgotten stones. The transformation happened continuously. Human memory simply stitched those quiet moments together. The universe changes with the same patience, except its seasons last millions or billions of years. Astronomers have learned to read those seasons. By studying the colors of stars, they estimate temperatures. By measuring brightness, they estimate size. By examining chemical fingerprints inside starlight, they reconstruct entire life stories. Every spectrum becomes a biography written in light. A blue star speaks of youth and enormous energy. A swollen red giant whispers of approaching old age. A white dwarf tells the story of a star that has already completed its brightest chapters. Our own sun belongs somewhere between those extremes. It is neither especially young nor especially old, roughly halfway through its stable life. Another 5 billion years remain before it begins its final transformation. That sounds comfortably distant, and for humanity, it certainly is. Entire civilizations rise and disappear within only a few thousand years. 5 billion years stretches so far beyond history that language almost loses meaning. Yet, on the cosmic calendar, even the sun lives only a modest lifetime. This introduces another gentle paradox. The brightest stars filling astronomy photographs are often the shortest lived. Their enormous masses create extraordinary pressure inside their cores. Fusion races forward with breathtaking intensity. They shine with dazzling brilliance. But they pay dearly for that beauty. Many exhaust their fuel in only a few million years. Smaller stars glow far less dramatically. They burn carefully, quietly. Their patience becomes their greatest strength. Nature repeats this lesson often. A rushing river reshapes stone quickly. Gentle rain nourishes fields for generations. Fireworks astonish the eye for seconds. Candlelight comforts an entire evening. Lasting beauty often arrives softly rather than loudly. The universe seems surprisingly fond of that principle, as astronomers surveyed thousands, then millions, then billions of stars. Another pattern slowly emerged. Galaxies were changing. Long ago, many galaxies produced stars at astonishing rates. Great clouds of hydrogen collapsed everywhere. Stellar nurseries glowed brightly. Young blue stars filled the darkness. Today, those same galaxies appear quieter, older, their brightest years already behind them. The cosmos is not merely aging star by star. Entire galaxies are aging together. Imagine visiting a bustling town decades after its greatest prosperity. The streets remain, the buildings stand, the memories linger. Yet fewer workshops operate. Fewer children play outside. The energy feels different. Nothing catastrophic occurred. Time simply continued its quiet work. Many galaxies now resemble those peaceful towns. Their greatest seasons of creation have slowly passed. This becomes the next obstacle in our journey. If galaxies once created stars so easily, why are they becoming quieter now? What invisible resource is slowly disappearing? The answer does not begin inside stars themselves. It begins inside vast, cold clouds, drifting silently between them. Invisible reservoirs waiting across unimaginable distances. Reservoirs that are slowly running dry. Our journey, therefore, moves away from the stars we admire. Instead, it turns toward the quiet darkness between them. Because sometimes the most important part of a story is not the light we see. It is the silent place where future light has not yet been born. The most important ingredient in a forest is not the tallest tree. It is the quiet soil beneath every root. You rarely notice it. It never attracts attention. Yet, without it, no seed can become a towering oak. The universe hides a similar secret. The future of every star depends upon something far less dramatic than the stars themselves. It depends upon immense clouds of cold hydrogen drifting almost invisibly through the darkness. Imagine standing outside on an autumn morning. A layer of fog rests across an empty field. At first glance, it appears still, featureless, almost lifeless. Yet within that gentle mist are countless tiny droplets, each following the invisible laws of temperature, pressure, and gravity. Cosmic gas clouds behave in much the same way. From a distance, they seem empty. Up close, they contain the raw material for entire generations of suns. Hydrogen is the simplest atom in existence. One proton, one electron. Nothing more. It formed during the first few minutes after the Big Bang, when the newborn universe cooled just enough for matter to become stable. Nearly every star that has ever shone began with those humble atoms. Every sunrise on Earth ultimately traces its origin back to hydrogen, created almost 14 billion years ago. For billions of years, galaxies acted like careful gardeners. Gravity slowly gathered these diffuse clouds into denser regions. As more gas accumulated, pressure quietly increased. Temperature rose. Eventually, the center became hot enough for nuclear fusion to begin. A new star awakened. Light spread outward. Darkness retreated. if only slightly. Another chapter of cosmic history quietly began. This process sounds almost effortless. In reality, it is astonishingly delicate. Gravity pulls inward, heat pushes outward, magnetic fields twist through the gas. Shock waves from exploding stars stir the clouds. Tiny differences grow into enormous consequences over millions of years. The birth of a star resembles bread rising inside an oven. The ingredients appear simple. The transformation requires remarkable balance. The night sky you know today exists because this balance succeeded countless trillions of times. Every bright point overhead represents a place where gravity patiently won its quiet argument against disorder. Yet, every victory consumed a little more of the available hydrogen. Every newborn star slightly reduced the material available for future generations. Imagine owning a vast reservoir, feeding every farm across an entire continent. Each year, the water level drops only a few inches. No one worries. The change seems insignificant. Decades pass, then centuries. Eventually, the shoreline has moved far enough that everyone notices. The decline was never sudden. It was simply too gradual for ordinary lives to recognize. The universe has been drawing from its own reservoir for nearly 14 billion years. Modern telescopes reveal something extraordinary. The peak era of star formation is already behind us. Around 10 billion years ago, galaxies produced new stars far more rapidly than they do today. Back then, the cosmos resembled a flourishing spring garden. Stellar nurseries glowed everywhere. Massive young stars illuminated enormous clouds of gas. Entire galaxies shimmered with fresh blue light. Today, the pace has slowed dramatically. Many galaxies have already exhausted much of the cold hydrogen needed to build new stars. Others lost gas through violent encounters with neighboring galaxies. Some watched energetic black holes heat surrounding material until it could no longer collapse. Different paths, the same destination. Less fuel, fewer births. The Milky Way still creates new stars. So do many neighboring galaxies, but the rhythm is quieter now. Less urgent, like an orchestra gradually lowering its volume after the most energetic movement of a symphony. The music continues. Yet something has unmistakably changed. This is not a crisis. It is aging. Everything familiar carries signs of it. A library acquires fewer new books. An old orchard produces fewer blossoms. A bustling train station grows calmer after midnight. None of these changes happen all at once. They unfold through countless ordinary moments. The universe seems to favor that same gentle rhythm. Even its greatest transitions arrive almost silently. Astronomers often compare galaxies to living ecosystems. Not because galaxies are alive in the biological sense, but because they recycle material continuously. One generation of stars manufactures heavier elements. When those stars die, they scatter carbon, oxygen, silicon, and iron into surrounding space. Future stars inherit those materials. So do future planets. Eventually, living creatures appear. Every breath you take contains atoms forged inside ancient stars that disappeared billions of years before Earth existed. In that sense, every ending quietly prepares another beginning. Yet this beautiful cycle contains a limit. Hydrogen cannot replenish itself forever. The universe began with a finite supply. Stars continually transform it into heavier elements. Although some hydrogen returns through various processes, the overall reservoir steadily shrinks. The cosmic garden still grows flowers, but the soil grows thinner with every passing age. Picture an elderly craftsman working inside a peaceful workshop. Around him remain shelves filled with precious wood, gathered over an entire lifetime. He still creates beautiful furniture. Each piece carries extraordinary care. Yet every finished table leaves the shelves slightly emptier. He cannot replace timber cuts centuries earlier. Eventually, only a few treasured boards remain, The workshop does not fail dramatically. It simply becomes quieter. Galaxies are approaching that same quietness, far into the future. Enormous clouds, capable of forming brilliant new stars, will become increasingly rare. The youngest stars will belong to an earlier age. Older stars will dominate the heavens. Night skies across surviving civilizations will slowly lose the dazzling blue giants that once illuminated the cosmos. Redder, cooler, longer-lived stars will inherit the stage. At first glance, that sounds like decline. In another sense, it represents extraordinary endurance. The loudest performers leave first. The patient ones remain. Nature has whispered this lesson since the beginning. Tall summer flowers bloom brilliantly, then vanish. Ancient pines endure harsh winters for centuries. Flash floods reshape valleys overnight. Gentle rivers carve mountains across ages. The longest stories rarely begin with the brightest light. This realization gently redirects our journey. We started by asking how the last star could possibly exist. We assumed the answer would involve something immense, perhaps a colossal blue giant, perhaps a spectacular explosion. Instead, the evidence points elsewhere. The final survivor will almost certainly be modest, small, patient, a star that never hurried, a star content to burn so slowly that entire galaxies fade while it barely notices the passing of time. To understand that remarkable future, we must leave behind the magnificent giants filling astronomy calendars. Our attention turns instead toward the quiet. Reddish stars, often overlooked through backyard telescopes. They shine softly. They ask for little. Yet, they possess a gift unlike any other object in the visible universe. They have more time than almost anything else ever created. If you have ever watched the last glowing ember inside a campfire, you already understand the beginning of this story. Long after the tall flames disappear, one small red ember quietly continues shining. It gives little light, almost no sound, yet hour after hour, it patiently outlasts the fire that once surrounded it. The universe appears to have built its longest-lived stars according to exactly the same principle. When most people imagine a star, they picture something resembling our sun, bright, golden, powerful enough to fill an entire sky with daylight. In reality, the most common stars are much smaller. They are called red dwarfs. They produce only a tiny fraction of the sun's light. Many would appear little brighter than a brilliant sunset if viewed from nearby planets. Some are so faint that the human eye could never notice them across interstellar distances. For a long time, astronomers underestimated these quiet stars. They seemed unremarkable, too dim, too ordinary. Large telescopes naturally focused upon dazzling giants and spectacular explosions. Bright objects always attract attention. Quiet endurance rarely does. Yet, as observations improved, a remarkable truth slowly emerged. Red dwarfs are not the exception. They are the rule. Nearly 3/4 of all stars in the Milky Way belong to this humble family. Imagine visiting a city where nearly every building is a modest cottage instead of a towering skyscraper. At first, the skyline might appear less dramatic. Then you realize the cottages stretch almost endlessly toward every horizon. The true character of the city was never defined by its tallest structures. It was defined by its countless quiet homes. The Milky Way tells the same story. The stars dominating photographs are only a tiny minority. The gentle red dwarfs quietly fill the vast majority of the galaxy. Their remarkable longevity begins with something beautifully simple. They burn their fuel slowly, very slowly. Gravity squeezes their cores less intensely than it does inside massive stars. Lower pressure means slower fusion. Slower fusion means less energy escapes each second. They shine gently because they consume hydrogen with extraordinary patience. Nature rewards that restraint with astonishing lifetimes. Our sun is expected to shine steadily for roughly 10 billion years. That already sounds unimaginably long. Human civilization has existed for only a tiny fraction of 1% of that span. Entire mountain ranges rise and erode within such immense intervals. Yet, beside a red dwarf, even the sun begins to resemble a hurried traveler. Many red dwarfs are expected to survive for trillions of years, not billions, trillions. The difference almost escapes intuition. 1 trillion seconds equals more than 30,000 years. 1 trillion years extends roughly 100 times longer than the current age of the entire universe. Some of the smallest red dwarfs may continue shining for 10 trillion years or more. Others could approach 100 trillion years before exhausting their fuel. No human mind naturally imagines such distances through time. We can only approach them slowly. Using comparison after comparison, imagine reading 1 page every day. Continue without missing a single morning. Eventually, you finish a novel. Then a library. Then countless libraries. A red dwarf would still have barely begun its lifetime. Time itself seems to slow beside these stars. There is another secret hidden inside them. Unlike larger stars, many red dwarfs mix their interiors almost completely. Fresh hydrogen from outer layers gradually circulates toward the core. Fuel rarely becomes trapped beyond reach. Imagine stirring a pot of soup continuously while cooking. Every ingredient remains available. Very little is wasted. Larger stars resemble layered cakes instead. Their fuel remains separated into distinct regions. Much of it can never reach the center where fusion occurs. Red dwarfs quietly avoid that inefficiency. The universe seems strangely economical. It wastes almost nothing inside its smallest stars. This efficiency changes everything about the far future. Long after stars resembling our sun disappear, countless red dwarfs will still illuminate scattered planetary systems. Entire eras of cosmic history will belong almost exclusively to these tiny crimson lights. If intelligent civilizations survive into those unimaginable ages, red dwarfs may become their most precious companions. Picture an old lighthouse standing after every neighboring building has vanished. Storms have passed. Harbors changed. Generations disappeared. Yet the lantern still turns patiently across the sea. Ships navigating those distant waters would treasure its quiet reliability far more than the forgotten brilliance of cities that no longer exist. Red dwarfs may one day become the lighthouses of the aging universe. Not every aspect of their nature feels comforting. Many young red dwarfs behave unpredictably. Powerful stellar flares erupt across their surfaces. Radiation surges through nearby space. Planets orbiting very close may struggle to preserve atmospheres. Life around such stars could face enormous challenges during their early history. Endurance does not always arrive with gentleness, yet patience changes many things. Over immense spans of time, many red dwarfs gradually calm. Their violent youth fades. Stability replaces turbulence. The same stars that once threatened nearby worlds may eventually become remarkably dependable sources of warmth for trillions of years. Nature often exchanges intensity for longevity. This introduces an intriguing possibility. Somewhere in the unimaginably distant future, while galaxies continue aging and brilliant stars become increasingly rare, civilizations might gather around these modest suns. Their skies would differ profoundly from ours. Few dazzling blue stars would remain. Stellar nurseries would have nearly vanished. The universe would feel quieter, older, more spacious. Yet these enduring little stars would continue offering light. Day after patient day, there is quiet beauty in that image. The greatest survivor is not the strongest, not the brightest, not the largest, simply the one that never hurried. That lesson reaches far beyond astronomy. Ancient trees outlive delicate flowers. Slow rivers outlast violent floods. Gentle voices often remain in memory longer than loud ones. The cosmos repeatedly favors persistence over spectacle. Perhaps that is one reason these small stars feel strangely comforting. They remind us that endurance can be its own quiet form of greatness. Still, another obstacle waits ahead. Even if trillions of red dwarfs continue shining across unimaginable ages, they cannot solve a deeper problem. The stars themselves remain scattered inside galaxies, and galaxies are not standing still. Space between them continues growing, slowly, relentlessly, patiently stretching until each island of light finds itself increasingly alone. The longest-lived stars may survive almost forever by human standards, but who will still be close enough to see them? Stand outside on a clear evening and look toward the horizon. The farther away a town is, the smaller its lights appear. First, the bright streets disappear. Then only a handful of distant windows remain. Eventually, even those tiny points fade into darkness. Nothing happened to the town itself. Distance quietly carried it beyond your sight. The future of the universe follows a surprisingly similar pattern. Although the distances involved are almost beyond comprehension, for much of human history, people imagined the heavens as fixed. Stars seemed permanently attached to an invisible dome. Galaxies had not yet been discovered, even after telescopes revealed countless distant systems. Many scientists still believed the universe itself remained essentially unchanged. That comforting picture lasted until the 20th century, when careful observations revealed something astonishing. Nearly every distant galaxy was moving away from us. At first, this sounded impossible. How could almost everything be receding at once? The answer required a completely different way of imagining space itself. Picture raisins inside a loaf of bread as it slowly rises in the oven. Each raisin notices every other raisin drifting farther away. No raisin sits at the special center of expansion. The dough itself stretches. Space behaves much the same way. Galaxies are not racing through an empty container. Instead, the fabric separating them gradually expands. Every billion years, the distances become a little larger. This expansion began with the Big Bang nearly 14 billion years ago. Yet for billions of years, gravity partially resisted it. Galaxies gathered into clusters. Enormous structures formed across the young cosmos. It was a dynamic balance. Expansion pulled outward, gravity pulled inward. Then another surprise appeared. The expansion was accelerating. Instead of slowing down, the universe gradually began stretching faster. Astronomers still debate the deepest nature of the mysterious influence responsible. We call it dark energy because we observe its effects while understanding remarkably little about its true identity. It does not glow. It casts no shadow. Yet, across the largest scales imaginable, it quietly shapes the future of everything. Imagine standing on an airport moving walkway while also walking forward. At first, your own steps matter most. Eventually, the walkway becomes so fast that its motion dominates everything. The accelerating expansion of space behaves in a similarly subtle way. Nearby galaxies remain bound together by gravity. Very distant galaxies slowly surrender to the expanding fabric between them. Our nearest large neighbor, the Andromeda Galaxy, is actually moving toward us. In several billion years, the Milky Way and Andromeda will merge into a single enormous galaxy. Stars will mostly pass one another harmlessly because the distances between them are immense. The night sky of any future civilization living through that event would become extraordinary. New streams of stars would arch across the heavens. Giant clouds of gas would ignite fresh bursts of star formation. It would appear dramatic beyond imagination, yet even that magnificent collision cannot resist the larger story forever. Beyond our local group of galaxies, the rest of the universe continues drifting away. Galaxy clusters separated by vast distances slowly become unreachable, not because they travel faster through space, because more space quietly appears between them. The distinction is subtle, yet it changes everything. Imagine writing two dots on the surface of a balloon. As the balloon inflates, the dots separate. Neither dot crawls across the rubber. The surface itself expands. Space follows a similar logic. Although in far more dimensions than everyday intuition comfortably accepts, this gradual stretching carries profound consequences. Light always travels at a finite speed. If distant galaxies move away quickly enough through expanding space, the light they emit struggles to bridge the ever-growing distance. Eventually, some galaxies cross a horizon beyond which their future light can never reach us. They do not vanish instantly. Their existing light continues arriving for immense spans of time, but new messages stop coming. The conversation slowly ends, one sentence at a time. That image feels unexpectedly emotional. Imagine exchanging letters with an old friend. At first, the replies arrive regularly. Then, months pass between messages. Eventually, no new letters appear. The friendship itself may remain. Yet, silence gradually replaces conversation. Humanity's relationship with the distant galaxies follows that same quiet pattern. Their ancient light still reaches us. Future light slowly loses the race against expanding space, billions of years from now. Astronomers living inside the merged Milky Way and Andromeda may look outward and discover almost nothing beyond their own galaxy. The distant universe will have slipped beyond visibility. Those future observers might reasonably conclude that only one great galaxy exists. The overwhelming evidence for the Big Bang could become nearly impossible to detect. Cosmic history itself would slowly disappear from view. Knowledge, like light, depends upon timing. We happen to live during a remarkably fortunate age. The expansion has not yet erased the evidence of our origins. We can still observe ancient galaxies. We can still measure the cosmic microwave background. We can still reconstruct the early chapters of existence. Future civilizations may inherit a quieter sky, a lonelier one. This transformation resembles walking through an old museum as each gallery gently closes behind you. Nothing inside the earlier rooms changes. You simply lose the ability to return. One by one, the doors become part of memory. The expanding universe quietly closes similar doors across unimaginable distances. Yet gravity continues preserving smaller communities. Our local group of galaxies remains bound together. The future merged galaxy will still contain hundreds of billions of stars. Countless red dwarfs will continue shining. Planets will still orbit. Black holes will still wait inside quiet galactic centers. Says life, if it survives, could continue for astonishing lengths of time within this isolated island. Isolation becomes the new obstacle, not extinction. Imagine surviving on an island surrounded by an endless ocean. The island provides food, shelter, and companionship. Yet every other shore has disappeared beyond the horizon forever. That is the destiny awaiting every gravitationally bound galaxy. Each becomes its own tiny archipelago, floating within an ever-expanding sea of darkness. As trillions of years pass, these islands will grow increasingly quiet. New stars become rarer. Ancient red dwarfs dominate the remaining light. Distances beyond the local galaxy become meaningless because nothing can cross them. The observable universe shrinks, not through destruction, but through separation. Our journey therefore changes once again. The question is no longer how galaxies disappear. They remain. The deeper question becomes who might remain inside them. If intelligent beings endure into these unimaginably distant ages, how would they preserve warmth, knowledge, and hope while surrounded by a cosmos growing steadily older and immeasurably quieter? That question leads us toward the last great caretakers of the fading universe. Imagine preparing a home for the longest winter anyone has ever known. Before the first snow arrives, you quietly gather firewood. You preserve food in cool cellars. You repair the roof. You insulate every window. None of these tasks feel dramatic. They are simply careful acts of patience. Now stretch that familiar picture beyond imagination. Replace one winter with trillions of years. Replace one family with an entire civilization. Replace firewood with the last reliable stars in the cosmos. Suddenly, preparation becomes the defining story of the far future. If intelligent life continues, far beyond humanity's own lifetime, it will inherit a universe very different from ours. The bright age of frequent starbirth will already be fading. Galaxies will have become quieter. The sky will no longer overflow with brilliant blue giants. Instead, small red dwarfs will dominate nearly every remaining source of natural light. These modest stars may become the most valuable resources any civilization could ever possess. It is tempting to imagine future societies surrounded by limitless technology, infinite energy, infinite knowledge, infinite solutions. The laws of physics gently discourage such dreams. Every civilization, regardless of its intelligence, must still obey the same fundamental rules governing energy, entropy, and time. Technology can delay certain problems. It cannot repeal nature itself. Think about a rechargeable battery. You may use it carefully, recharge it efficiently, protect it from damage. Yet, every cycle slowly changes it. Eventually, its capacity declines. Good engineering extends usefulness. It does not create endless renewal. The future universe follows a similar rhythm. Resources remain available for astonishing spans of time, but they are never truly infinite. Energy will become increasingly precious. Today, humanity receives abundant sunlight every morning without effort. Future civilizations living around long-lived red dwarfs may treasure every watt far more carefully. Waste could become almost unthinkable. Every photon might serve multiple purposes before finally escaping into space. Entire cities could operate with astonishing efficiency simply because survival rewards patience. This idea already exists in small ways around us. During harsh winters, people naturally become more careful with heat. Doors remain closed. Fires burn steadily instead of fiercely. Nothing feels extravagant. Every small decision quietly extends comfort. The distant future may encourage similar habits on a cosmic scale. Astronomers and physicists sometimes imagine civilizations capable of surrounding stars with enormous structures designed to collect much of their energy. These hypothetical ideas, often called Dyson swarms, do not require impossible physics. Instead of one gigantic shell, countless satellites could orbit a star, harvesting sunlight with extraordinary efficiency. Whether any civilization ever constructs such systems remains unknown. Yet the concept illustrates an important truth. As stars become rarer, using their energy wisely becomes increasingly valuable. Imagine standing beside a slow mountain stream during a drought. You would never allow fresh water to spill carelessly away. Every drop matters. Future civilizations may eventually treat starlight with similar reverence. Not because stars suddenly become weaker, because every surviving star becomes irreplaceable. Knowledge itself may also become a precious resource. Civilizations lasting millions or billions of years face an unusual challenge. Memory fades, records disappear, languages evolve. Even stable societies struggle to preserve information across relatively short periods. Human history already demonstrates this repeatedly. Libraries burn, empires collapse, ancient texts vanish. Imagine protecting knowledge not for centuries, but for trillions of years. The task becomes almost unimaginable. Perhaps future beings would store history inside remarkably durable materials. Perhaps they would continually copy information into newer forms. Perhaps memory itself would become one of their highest cultural responsibilities, every generation quietly handing the past to the next. Much as families today preserve treasured photographs or handwritten letters, there is something deeply moving about that possibility. Across unimaginable ages, someone might still remember stars that disappeared long before their ancestors were born, Someone might tell stories about bright galaxies no longer visible. Someone might describe a universe overflowing with youthful light. Those stories would become legends, not because they were fictional, because they belonged to an almost unreachable past. Consider elderly people describing neighborhoods that no longer exist, streets renamed, buildings demolished, parks transformed. Younger listeners struggle to picture the vanished landscape, yet the memories remain genuine. Future civilizations may inherit similar stories about the early cosmos, tales of countless galaxies, brilliant nebulae, frequent supernovas, skies richer than anything they themselves have ever witnessed. The emotional distance may exceed the physical one. There is another challenge. Time itself changes perspective. A creature living only 1 year experiences seasons very differently from a person living 80 years. Likewise, civilizations surviving for trillions of years may perceive patience in ways impossible for us to imagine. Waiting 1 million years could seem almost ordinary. Planning projects lasting hundreds of millions of years might become entirely reasonable. The rhythm of existence stretches alongside survival. Nature already hints at this principle. Mountains reshape rivers without urgency. Coral reefs grow grain by grain. Glaciers carve valleys while appearing perfectly still. The greatest transformations rarely hurry. Perhaps truly ancient civilizations would resemble these quiet processes. Calm, deliberate, never rushing because time itself has become their greatest companion. Yet even perfect patience cannot overcome every obstacle. No civilization controls the stars themselves. Eventually, each cherished red dwarf continues consuming its remaining hydrogen, incredibly slowly, yet relentlessly, one after another. Even these extraordinary survivors approach old age. Their light remains steady for spans almost beyond language. Still, forever remains just beyond their reach. Imagine caring for the world's oldest tree. Generation after generation protects it. Storms pass. Kingdoms rise and vanish. Centuries become millennia. The tree survives them all. Then, after an age beyond memory, even it quietly reaches its natural end. No failure occurred. No mistake was made. Life simply completed its longest chapter. The same quiet dignity belongs to the final stars. One day, among all the surviving lights scattered through an aging cosmos, there will remain only a single luminous star still producing fusion inside its heart. Every other natural sunrise will already belong to history. That lonely survivor has waited longer than every civilization, longer than every galaxy's brightest age, longer than almost every structure ever formed. Our journey now turns toward that extraordinary beacon, not because it is the brightest, but because it is the last. Imagine sitting alone in a quiet house after everyone else has fallen asleep. One candle still burns on the table. Every other room has surrendered to darkness. The silence feels different now, not empty, simply aware of the single remaining light. The far future of the universe may eventually resemble that peaceful room. Across distances so immense that language begins to lose its usefulness, one final star could continue shining after every other natural sun has already faded into memory. Reaching that moment requires patience beyond anything the human mind naturally understands. Trillions upon trillions of years will have passed. Entire generations of red dwarfs will have quietly completed their long lives. Galaxies will have become ancient islands surrounded by unimaginable emptiness. The brilliant age of youthful stars will exist only as distant history, preserved perhaps in stories, mathematics, or fading archives maintained by civilizations fortunate enough to survive. The final star will almost certainly not be spectacular. It will not dominate the sky with dazzling brilliance. It will not explode with magnificent colors. Nature rarely ends its longest stories with fireworks. Instead, the last surviving star will probably belong to the smallest class of red dwarfs ever formed. A star so economical with its fuel that every second of fusion resembles the careful breathing of someone peacefully asleep. While massive stars raced through existence, this quiet little sun barely hurried at all. Its light would appear deep orange or crimson, gentle rather than overwhelming. A nearby planet would experience daylight, unlike Earth's bright blue mornings. Shadows would be softer. Sunsets might last longer. The sky itself could carry subtle colors unfamiliar to human eyes. Life, if it existed there, would grow beneath a patient star that seemed almost timeless. Imagine an old clock resting in a quiet room. Its pendulum still swings steadily after every newer clock has stopped. Visitors no longer admire its appearance. They admire its persistence. The final star becomes something similar, not an object celebrated for power, but for endurance. Every remaining sunrise becomes a quiet reminder that the age of stars has not completely ended. Around that lonely sun, space would feel profoundly different from the cosmos we know today. Look outside tonight, and the Milky Way stretches across the heavens like a river of pale light. Countless neighboring galaxies still surround us, even if many require telescopes to see clearly. In the era of the final star, that richness will be gone. Expansion will have carried almost every distant galaxy permanently beyond observation. The sky may appear astonishingly empty. Darkness itself becomes the dominant landscape. Silence acquires a new meaning in such a universe. Today, the night carries countless invisible signals. Pulsars rotate, quasars radiate, young stars ignite. Supernovas occasionally bloom. The cosmos remains busy, even when human senses cannot detect it. During the era of the last star, those events become extraordinarily rare. The universe settles into a calm, unlike anything experienced during its youthful ages. There is something strangely beautiful about that image, not because loneliness is beautiful, because persistence is. Think of an elderly lighthouse keeper tending the same beacon after every nearby harbor has closed. The ships no longer arrive in great numbers. Trade routes have shifted elsewhere. Yet each evening, the lantern is still lit. Not because many travelers remain, because one traveler might still need its light. The final star resembles that lighthouse. Its existence quietly refuses complete darkness. Would anyone still be there to witness it? Science cannot answer that question. Life depends upon many fragile conditions. Intelligence depends upon even more. Predicting civilizations across trillions of years quickly becomes speculation. Perhaps no observers remain. Perhaps countless descendants of today's life still thrive around ancient red dwarfs. Perhaps entirely different forms of consciousness emerge, adapted to realities we cannot imagine. Whatever the answer, the star itself continues shining. It does not require admiration. Fusion cares nothing for applause. Hydrogen quietly becomes helium. Energy escapes. Light travels outward. The same simple physics that illuminated Earth's first oceans continues faithfully until almost the final chapter of cosmic history. There is comfort hidden inside that consistency. The universe changes enormously. Its laws do not. Gravity remains patient. Light keeps traveling. Entropy continues its silent work. These dependable rhythms connect every age of existence, from the birth of the first stars to the lonely endurance of the last. Imagine holding an old family recipe written generations ago. The handwriting belongs to someone long gone. The kitchen itself may have changed. The house may even have disappeared, yet following the recipe still produces familiar bread. Some patterns survive because they are rooted deeper than memory. The laws of physics resemble those recipes. Civilizations come and go. Galaxies evolve. Stars disappear. Yet the underlying instructions remain astonishingly faithful. Even the last star cannot escape those instructions. Very gradually, its hydrogen supply diminishes. The process unfolds almost unimaginably slowly. Millions of years pass like quiet afternoons. Billions resemble brief seasons. trillions become ordinary chapters. The star notices nothing. It simply continues converting matter into light with extraordinary patience. Eventually, however, even patience reaches its natural limit. The core changes. Fusion weakens. The balance between gravity and pressure slowly shifts. No sudden catastrophe appears. No cosmic alarm sounds. The ending approaches exactly as the beginning unfolded, quietly, like autumn arriving leaf by leaf rather than all at once. This realization introduces the deepest obstacle yet. We have spent our journey following the longest-lived source of natural light in existence. We discovered the greatest survivor the stellar universe can produce, yet even this remarkable beacon cannot shine forever. One sunrise remains, then another, then, after an age beyond imagination, the final sunrise arrives without anyone recognizing its uniqueness. Nothing in the light itself announces that history is ending. Only afterward does the truth become clear. The age of stars has quietly reached its conclusion. What follows is not another generation, not another dawn, only the long, gentle arrival of a cosmos learning how to exist without sunlight at all. Have you ever watched the final colors disappear after sunset? At first, the horizon still glows with soft orange light. Then, pink slowly fades into gray. A few moments later, even the gray quietly dissolves into night. There is rarely a single instant when you can say, "Now daylight has ended." Instead, darkness arrives through countless gentle changes. The universe will experience the death of its final star in much the same way. There will be no audience counting backward, no great cosmic ceremony, no final announcement echoing across space. The last star will simply continue its ordinary routine until one ordinary day becomes its last. Imagine standing beside an ancient oak tree that has survived for 1,000 years. Every morning, it greets the sunrise exactly as it always has. Birds still visit its branches. Wind still moves through its leaves. Nothing about the final morning appears unusual. Only later do people realize they witnessed the tree's final dawn. History often hides inside completely ordinary moments. The last star carries the same quiet dignity. For trillions upon trillions of years, gravity and fusion maintained a delicate balance inside its heart. Gravity pressed inward without rest. Fusion pushed outward with gentle persistence, as long as those forces remained equal. The star continued shining. Light escaped into surrounding darkness. Warmth reached any nearby worlds. Time itself seemed almost powerless against such patience. Eventually, however, the remaining hydrogen becomes too scarce. Fusion slows, pressure weakens, gravity slowly gains the upper hand. Nothing dramatic happens at first. The star does not suddenly explode. It does not collapse in spectacular fashion. Small red dwarfs are simply too modest for such endings. Instead, their brilliant careers conclude with remarkable restraint. The light gradually softens. The temperature falls. The familiar glow becomes increasingly faint across unimaginable ages. Picture an old music box whose spring is almost fully unwound. The melody does not stop halfway through a note. Each movement simply becomes a little slower, a little quieter, until finally, the last note gently fades into silence. You cannot always identify the exact second when music becomes memory. The final star ends its life with that same graceful quietness. For any civilization fortunate enough to live nearby, the change would unfold so slowly that countless generations might never notice it directly. One lifetime would seem almost identical to the previous one. Only records preserved across millions or billions of years would reveal the gradual decline. The star itself would become a lesson in patience, its farewell written not in moments, but in epics. Then one day, fusion finally ceases. No new light is created inside the core. The ancient balance disappears forever. Gravity quietly compresses the remaining stellar material until a new object emerges. The shining star becomes a white dwarf, small, dense, incredibly hot at first. yet no longer producing fresh energy through nuclear fusion. What remains is simply stored heat, slowly escaping into space. Imagine removing a loaf of bread from an oven. Even after the oven is switched off, the bread remains warm for a long time. Touch it immediately, and it feels hot. Return hours later, and it has cooled. Nothing continues heating it. It merely releases energy gathered earlier. A white dwarf behaves similarly. It shines because it remembers its former heat, not because new fire still burns inside. At this point, something extraordinary has happened. The stellar age has ended. No natural star anywhere in the observable universe continues creating fresh sunlight. The word sunrise quietly loses its meaning across countless abandoned planets. Dawn never returns. Mountains that once glowed beneath morning light remain frozen in endless night. Oceans, if any survived until then, became solid ages earlier. Clouds no longer drift across bright skies. Shadows no longer move with passing afternoons, and entire landscapes wait beneath permanent darkness. Unchanged for intervals beyond imagination, the emotional weight of this future comes not from violence. It comes from absence. Imagine returning to a childhood home after everyone has moved away. The furniture is gone. The familiar voices have disappeared. Nothing terrible is happening inside the empty rooms, yet the silence feels almost tangible because memory quietly fills every corner. The universe after the final star carries that same feeling. Everywhere remain traces of what once existed. Warm worlds, bright skies, young galaxies. They are not erased. They are remembered by the structures left behind. Even then, darkness is never completely empty. White dwarfs continue glowing faintly for unimaginable lengths of time. Neutron stars quietly spin. Black holes wait with infinite patience. Planets continue orbiting invisible remnants long after their original suns have disappeared. Gravity never abandons its work. Motion continues. Only the light changes. This distinction matters. People often imagine the end of the universe as complete destruction. Nature prefers quieter endings. The stage remains standing. The actors simply leave one by one. There is something unexpectedly peaceful in that image. A theater after the audience has gone home. Dust settles onto empty seats. Curtains hang motionless. The performance is over. Yet the building itself still exists beneath the silent night. The cosmos after its final sunset resembles that empty theater. History lingers inside every object, even when no voices remain to tell it. Still, another transformation quietly continues. White dwarfs cannot remain warm forever. Given enough time, even their stored heat gradually escapes into the endless darkness. Their faint glow weakens year after year. Then, million after million years. Then billion after billion. Eventually, they cool beyond visibility altogether. The last star has disappeared. Its memory slowly cools beside it. What remains is something stranger than darkness. A universe filled with stars that are no longer stars. Ancient embers drifting through infinite night. Their journey has not yet ended. In many ways, it has only entered an even quieter chapter. If you have ever picked up a smooth stone after sunset, you already know something about the future of stars. During the day, the stone quietly absorbed warmth from the sun. Long after darkness arrived, it continued releasing that stored heat into the cool evening air. Eventually, almost without notice, it became the same temperature as everything around it. Nothing dramatic happened. The warmth simply drifted away. The oldest stars in the universe will experience an ending remarkably similar to that quiet stone. After fusion ends, a white dwarf begins an unimaginably long cooling process. At first, it still shines with brilliant white light, not because new energy is being created, only because enormous heat remains trapped inside its incredibly dense interior. Every second, a tiny fraction of that ancient warmth escapes into space. There is no fire left, only memory. White dwarfs are among the strangest objects in nature. Imagine compressing something as massive as the Sun until it becomes roughly the size of Earth. Matter behaves in unfamiliar ways under such extraordinary pressure. A teaspoon of white dwarf material would weigh many tons on Earth. Atoms are squeezed closer together than everyday experience can easily imagine. Gravity transforms ordinary matter into something almost unrecognizable. Yet despite their incredible density, white dwarfs remain peaceful objects. They no longer rage with nuclear fusion. They no longer manufacture new light. They simply cool, patiently, silently, for trillions upon trillions of years. Imagine removing glowing charcoal from a fireplace. The brightest pieces slowly fade from orange to red, then from red to dark gray. Eventually, they become indistinguishable from ordinary stones. A white dwarf follows almost exactly the same pattern, except the cooling requires periods of time so vast that the current age of the universe becomes only the opening chapter. Astronomers have given a name to the final stage of that journey, a black dwarf. Despite the dramatic name, no black dwarfs are believed to exist today. The universe is simply too young. Nearly 14 billion years have passed since the Big Bang. Yet even the oldest white dwarfs have not had enough time to cool completely. The first true black dwarf belongs entirely to the future. Picture an old iron stove inside an abandoned cabin. The fire disappeared centuries ago. The metal has long since become cold. Yet, the stove still occupies the room exactly where it always stood. A black dwarf resembles that forgotten stove. The furnace remains. The fire has vanished forever. These silent, stellar remnants gradually become some of the most common objects in the distant cosmos. Ancient suns scattered across aging galaxies, invisible unless another source of light happens to illuminate them. Entire planetary systems may continue orbiting these dark remnants, faithfully following gravitational paths established trillions of years earlier. Imagine standing on one of those worlds. There is no sunrise, no sunset, no dawn chorus from birds. The sky never brightens. Mountains cast no moving shadows because there is no nearby light to create them. Frozen plains stretch beneath permanent darkness. The stars once visible overhead have almost entirely disappeared. Occasionally, a distant white dwarf or another faint object might briefly interrupt the blackness. Otherwise, the heavens resemble an endless velvet ocean without a horizon. It sounds lonely, yet loneliness itself may lose meaning after enough time. Creatures evolving in such an environment, if any ever existed, might consider endless darkness perfectly ordinary, just as humans instinctively expect daytime because we evolved beneath an active sun. Another form of life could accept permanent night as the natural condition of existence. Perspective quietly shapes reality. Nature repeatedly teaches this lesson. Deep beneath Earth's oceans, entire ecosystems flourish without sunlight. Around hydrothermal vents, life depends upon chemistry rather than daylight. Creatures there do not miss the sun. Many have never encountered it. They simply inhabit a different version of normal. The distant universe reminds us that familiarity often disguises extraordinary fortune. There is another quiet consequence of cooling stars. Planets continue traveling. Gravity survives the death of sunlight, even after their stars become white dwarfs. Then, black dwarfs. Planets often remain loyal companions. They circle invisible remnants exactly as they once circled living suns. Their years continue. Their orbits remain astonishingly precise. Motion persists despite the disappearance of light. Imagine an old clock whose face has become too dark to read. The hands still move. The gears still turn. Time continues whether anyone observes it or not. The universe behaves similarly. Celestial mechanics remain beautifully faithful long after illumination fades. This persistence carries unexpected beauty. The cosmos does not collapse into chaos after the stellar age. It becomes quieter, slower, more subtle. History leaves behind architecture even after the builders have gone. Old planetary systems become cosmic ruins. ancient orbits become forgotten roads. Black dwarfs become silent monuments to stars that once warmed worlds. Walking through the ruins of an ancient city often inspires reflection rather than fear. Empty streets suggest countless lives once lived there. Broken walls hint at conversations long finished. The structures remain because memory sometimes survives inside stone. Black dwarfs preserve similar memories. Every one of them once illuminated planets. Every one once transformed hydrogen into light. Every one belonged to an earlier age when the universe felt warmer and younger. Yet another challenge quietly approaches. Cooling alone does not end the story. Gravity continues shaping everything. Scattered through nearly every large galaxy, wait objects far stranger than white dwarfs or frozen planets. They possess no surface, no solid ground. Not even light escapes their grasp. Throughout every previous age, they quietly watched stars being born, galaxies colliding, and civilizations perhaps rising and falling. They have been patient from the beginning. In the darkness after the last star, their patience finally becomes the dominant force. The next chapter belongs not to light, but to gravity itself. Have you ever watched water disappear into a quiet drain? At first, the movement seems gentle, almost effortless. A floating leaf circles once, then again. Each turn brings it a little closer to the center until, without any sudden drama, it quietly vanishes from sight. Gravity often works like that, patient, relentless, never raising its voice. In the unimaginably distant future, after the stars have faded, gravity becomes the universe's last great storyteller. Black holes have fascinated people for generations because they seem mysterious. Popular culture often imagines them as cosmic monsters, endlessly swallowing everything nearby. Reality is quieter. A black hole does not wander through space searching for victims. It simply waits. Like every other massive object, it shapes the motion of anything passing close enough. Distance remains the deciding factor. If our sun were magically replaced by a black hole of identical mass, Earth would continue orbiting almost exactly as it does today. The light would disappear. The warmth would vanish. Life would quickly become impossible, yet gravity itself would barely change. The orbit remains. The invisible center simply becomes much stranger. That simple thought reveals an important truth. Gravity cares about mass, not brightness, not beauty, not whether a star is alive or dead. Throughout every age of cosmic history, black holes have quietly occupied the centers of galaxies. Some formed from collapsing massive stars. Others grew into supermassive giants containing millions or even billions of times the sun's mass. The Milky Way itself circles such an invisible giant. Hidden behind dense clouds near the galactic center waits Sagittarius, a star, silently guiding the motions of countless stars. For most of the universe's history, these black holes shared the stage with brilliant galaxies filled with sunlight. Their influence was important, but rarely dominant. Stars still illuminated the sky. Nebulae still glowed. Young galaxies continued creating fresh generations of light. The distant future changes that balance. As stars disappear, black holes remain. Imagine an old harbor after every ship has departed. The lighthouse is dark. The warehouses stand empty. Only the massive stone breakwater continues, resisting the sea exactly as it always has. Black holes resemble those ancient structures, long after the brightest features of the cosmos have vanished. Gravity continues shaping everything around them. Objects passing nearby may still fall inward. Lonely planets, white dwarfs, black dwarfs. Occasionally, entire stellar remnants slowly drift close enough to become trapped. They spiral inward over immense stretches of time, gradually releasing energy before finally crossing the event horizon. For a brief period, the black hole shines again through the glowing material surrounding it, even in the age of darkness. Gravity occasionally creates small islands of light, not through fusion, through falling. Imagine rubbing your hands together on a cold morning. Friction produces warmth from motion. Material spiraling toward a black hole behaves in a surprisingly similar way. Gravity accelerates the matter. Collisions heat it enormously. Light appears once again, not because a new star has been born, but because motion itself becomes heat. These brief flashes remind the aging universe that energy can still change form even after the stellar age has ended. Yet these moments become increasingly rare. The cosmos grows emptier. Objects spread farther apart. Encounters happen less often. Black holes wait with extraordinary patience. Patience, once again, becomes the defining quality of the far future. There is another astonishing discovery made by modern physics. Black holes are not completely eternal. For centuries, scientists believed nothing could ever escape them. Then, during the 20th century, Stephen Hawking showed that quantum physics changes the story in subtle ways. Tiny quantum effects near the event horizon allow black holes to lose unimaginably small amounts of energy. The process is now known as Hawking radiation. The name sounds dramatic. The reality is almost unbelievably quiet. A large black hole loses energy so slowly that its evaporation requires timescales beyond ordinary comprehension. A supermassive black hole may survive for around 10 to the power of 100 years or even longer. Writing the number is simple. Understanding it is another matter entirely. If every second since the Big Bang became one grain of sand, you would still not come remotely close to representing such an interval. Once again, the universe chooses patience over spectacle. Imagine placing a single drop of water onto an enormous frozen lake. Each century, one more drop quietly evaporates. No observer notices the change, yet given enough time, even that impossible task eventually finishes. Hawking radiation behaves with similar gentleness. Every unimaginably long age removes only the tiniest fraction of a black hole's mass, eventually. However, even giants surrender. The largest structures in galaxies slowly fade, not through collision, not through explosion, simply through relentless persistence. Nature seems deeply committed to this pattern. Mountains become valleys, one grain at a time. Coastlines retreat, one wave at a time. Black holes themselves disappear, one tiny quantum whisper at a time. This realization changes our understanding of permanence. Earlier, we believed stars were eternal. Then we discovered they age. Later, we imagined black holes lasting forever. Now even they reveal quiet mortality. The universe appears reluctant to grant absolute permanence to anything. Everything participates in time. Everything changes. Only the rhythm differs. Standing beside the ocean offers a gentle analogy. Waves constantly reshape the shoreline. During a single afternoon, the beach appears almost identical. Return after thousands of years, and the coastline has transformed completely. Slow processes often become the most powerful, precisely because they never stop. Hawking radiation belongs to that family of quiet changes. As black holes gradually evaporate across incomprehensible ages, another profound transformation approaches. The great engines of gravity slowly disappear. The remnants of stars continue cooling. Galaxies lose even their darkest anchors. Matter itself becomes increasingly isolated inside an expanding sea of emptiness. For the first time, physicists begin asking a question even stranger than the fate of stars or black holes. What if matter itself cannot last forever? What if protons, the tiny building blocks inside every atom around you tonight, also possess their own distant ending? If that possibility is true, then the future becomes quieter still. Not only light, not only stars, not only black holes, even the very substance of existence may slowly learn how to fade. Take an old photograph from a drawer. Leave it beside a sunny window for many years. At first, nothing seems different. The smiles remain clear. The colors still feel familiar. Then, almost without notice, the blue sky begins to soften. Faces lose their sharpness. Tiny details quietly disappear. Eventually, the picture becomes only a faint memory of what it once preserved. Matter itself may experience a similarly patient fading across the deepest future of the universe. Everything around you appears wonderfully solid. The chair beneath you, the walls around you, the air entering your lungs, even your own body. It is easy to imagine these things as permanent building blocks. Modern physics offers a gentler perspective. Every object consists of atoms. Every atom contains even smaller particles. Protons, neutrons, electrons. These tiny structures create nearly everything familiar to human experience. For many decades, physicists have wondered whether protons are truly eternal. No experiment has ever observed one decay. Every proton we have measured remains astonishingly stable. Yet several important theories suggest that stability may not be absolute. Instead, protons could possess lifetimes so unimaginably long that no human civilization has yet existed long enough to witness even a single natural example. Imagine owning a clock designed to ring only once every trillion years. You could watch it faithfully every day of your life. Your children could continue the observation. So could countless future generations. The clock would remain perfectly silent. That silence would not prove it can never ring, only that its rhythm lies far beyond ordinary experience. Proton decay occupies a similar place within modern science. It remains a possibility, a quiet hypothesis patiently awaiting evidence. If protons truly can decay, the consequences reach astonishingly far. White dwarfs, black dwarfs, planets, asteroids, even the cold stones drifting through ancient galaxies would slowly lose their identity. Not through collisions, not through heat, simply because the particles composing them gradually transform into lighter forms over unimaginable stretches of time. Imagine an enormous sandcastle standing beside a calm sea. There are no waves, no wind, no footsteps. Instead, one grain quietly disappears every 1,000 years. The castle appears unchanged for ages beyond memory. Yet eventually, every tower softens, every wall lowers, every doorway fades. The destruction arrives so slowly that no observer could ever point to a single dramatic moment. Nature often prefers these quiet departures. The same may be true for matter itself. If proton decay exists, entire planets eventually become ghostly relics. Mountains dissolve atom by atom. Ancient moons slowly surrender their substance. Black dwarfs quietly shrink. Even objects untouched by every other cosmic process gradually fade into increasingly diffuse clouds of elementary particles and radiation. The universe becomes simpler, not because something new appears, because complexity gently leaves. This possibility introduces an unexpected emotional response. For most of history, humanity feared sudden endings, floods, earthquakes, storms, war. Yet the deepest future imagined by physics contains almost none of those dramatic events. Instead, existence itself resembles an old melody growing softer with every repetition until only silence remains. There is surprising peace inside that image, not because endings are easy, because they arrive without violence. Nature whispers rather than shouts. Of course, honesty requires an important reminder. No experiment has confirmed proton decay. The standard model of particle physics treats the proton as stable. Several grand unified theories predict otherwise. Modern detectors buried deep beneath mountains continue searching patiently for evidence. Vast underground laboratories monitor immense volumes of water or other materials, hoping to witness the extraordinarily rare signature of a single decaying proton. So far, nothing. Only silence. Science treats that silence with respect, not disappointment. Every unanswered question becomes another invitation to keep looking. That humility is one of science's quiet strengths. It willingly admits uncertainty. The universe owes us no easy answers. Imagine listening for a distant bird in a quiet forest. You wait. Minutes pass, then hours. The absence of birdsong does not prove the bird never existed. It simply means the forest has not yet revealed its secret. Physicists approach proton decay with similar patience. Observation always comes before certainty, whether protons ultimately decay or not. Another truth remains unchanged. Time continues. Entropy continues. The universe keeps moving toward greater simplicity. Stars become remnants. Remnants become colder. Galaxies become quieter. Expansion separates everything further. Each chapter gently prepares the next. This remarkable consistency gives the future an almost musical quality. Themes introduced near the beginning quietly return. Patience, transformation, persistence. Nothing truly escapes them. Even uncertainty becomes part of the rhythm. Suppose proton decay never occurs. Matter would remain astonishingly durable. Cold stellar remnants could survive almost indefinitely, interrupted mainly by gravitational encounters and the unimaginably slow evaporation of black holes. Suppose proton decay does occur. Then, matter itself gradually joins the long procession of endings already experienced by stars and galaxies. Either path leads toward increasing stillness. Either path reminds us that permanence remains extraordinarily rare. Think again about that faded photograph. Its greatest value never depended upon perfectly preserving every color. Its value came from reminding someone that a beautiful moment once existed. Perhaps the universe works similarly. Perhaps every galaxy, every star, every planet participates in a story whose meaning does not depend upon lasting forever. The story matters because it happened, not because it refuses to end. That gentle realization are to prepare us for an even stranger destination. If stars disappear, if galaxies grow isolated, if black holes slowly evaporate, if even matter itself eventually fades, then what remains? Not objects, not sunlight, not familiar landscapes, only time itself, or perhaps something even quieter than time. Our journey now enters an age where ordinary intuition finally reaches its limit, an age measured not by civilizations, not by galaxies, but by numbers so immense that change itself begins to resemble complete stillness. Have you ever stood in a quiet valley and listened to your own voice echo back from distant hills? At first, the reply is clear. Then each repetition grows softer, more distant, harder to distinguish from silence. Eventually, you can no longer tell whether the echo has ended or whether your ears simply cannot hear it anymore. Time itself begins to resemble that fading echo when we follow the universe beyond the disappearance of stars, galaxies, and perhaps even matter. Human beings naturally measure time through change. Morning becomes afternoon, summer becomes autumn, children become adults, trees grow taller, mountains slowly wear away. Without change, time becomes strangely difficult to recognize. Imagine entering a perfectly quiet room with no windows, no clocks, and no sounds. Sit there long enough. Minutes begin to lose their sharp edges. Hours become difficult to estimate. Your mind quietly searches for events to divide one moment from another. Time feels slower because fewer things are happening. Now extend that experience across the entire universe. Most familiar events have already disappeared. There are no new stars forming, no bright galaxies colliding, no frequent supernovas scattering fresh elements into space. The grand fireworks of cosmic youth belong to an unimaginably distant past. The remaining universe changes so slowly that entire trillions of years may pass with almost nothing noticeable occurring. This does not mean time has stopped, only that its rhythm has become extraordinarily gentle. Physicists sometimes write astonishing numbers to describe these eras. 10 raised to the 100th power? 10 raised to the 1000th. Even larger values appear in certain theoretical discussions. Reading such numbers is easy. Feeling their meaning is impossible. The human brain evolved to count footsteps, seasons, and generations. It did not evolve to imagine intervals requiring entire pages simply to write their digits. So perhaps another comparison serves us better. Imagine reading one page of a book every million years. Not every day, not every century, every million years. Before reaching the final chapter, many mountains on Earth would have disappeared through erosion. Continents would have rearranged themselves countless times. Entire species would have emerged and vanished. Yet compared with the deepest future, even that unimaginable pace remains astonishingly fast. The farther we travel, the quieter the universe becomes. Not emptier alone, quieter. Silence itself acquires texture. Picture a vast ocean at dawn, before even the light breeze begins. The water appears almost perfectly smooth. Small ripples still exist, but they require careful attention to notice. The far future resembles that calm sea. Motion never completely disappears. Tiny changes continue. Quantum processes persist. Gravity quietly shapes isolated remnants. Yet, compared with the energetic universe of today, everything feels almost motionless. This creates a curious philosophical question. If change becomes nearly impossible to observe, what does the passage of time actually mean? Physics offers one answer. Time does not require human observation. The equations continue. Entropy continues increasing. Processes continue unfolding according to natural law, whether anyone witnesses them or not. Yet conscious experience suggests another perspective. We understand time through memory, through comparison, through events. Without events, the emotional texture of time begins to dissolve. Think about a peaceful afternoon spent watching gentle rain through a window. An hour passes almost unnoticed. Contrast that with waiting anxiously for important news. Every minute feels stretched. The clock moves identically in both situations. Your experience changes because your awareness changes. The deepest future invites us to imagine a universe where meaningful events themselves become incredibly rare. Perhaps that rarity becomes its own kind of beauty. Ancient Japanese gardens often celebrate empty space as carefully as stone or water. Silence inside music gives melody room to breathe. Long pauses during conversation sometimes communicate more than words themselves. The aging universe appears to embrace that same quiet elegance. Less activity does not necessarily mean less meaning. Sometimes it simply invites deeper reflection. If any conscious beings survive into these remote ages, their relationship with time would almost certainly differ from ours. Waiting 1,000 years might resemble waiting through a single evening. Planning across millions of years could feel perfectly ordinary. Their patience would not come from extraordinary discipline. It would arise naturally from living inside a slower cosmos. Nature already hints at this possibility. Certain trees live for thousands of years. Some colonies of coral survive across astonishing spans. Glaciers reshape landscapes with movements almost impossible to perceive directly. Longevity quietly changes perspective. The universe extends that lesson beyond every familiar scale. There is another remarkable consequence. History itself becomes increasingly difficult to reconstruct. Many records vanish. Stars that once served as reference points no longer exist. Entire galaxies disappear beyond the expanding horizon. Future observers inherit fewer clues about the distant past. Imagine trying to understand an ancient civilization after nearly every building, every document, and every road has disappeared. The task becomes one of careful inference rather than direct observation. Future minds may face exactly that challenge while attempting to understand the brilliant universe we know today. Perhaps they would discover faint traces, subtle patterns, ancient radiation, quiet mathematical signatures, enough to suspect that the cosmos was once very different, not enough to experience it directly. That thought carries unexpected tenderness. We often assume knowledge steadily increases forever. The future reminds us that some knowledge depends upon living at the right moment. We are fortunate. We inhabit an era where the evidence of cosmic history still surrounds us. The oldest light still reaches Earth. The youngest stars still form. The story remains readable. One day, much of that cosmic library may quietly close, and still, something remains. Not certainty, not complete understanding, only the enduring echo that a magnificent story unfolded long before the silence arrived. That echo carries us toward our final philosophical destination. If almost every witness disappears, if almost every light fades, if even history itself becomes difficult to recover, then what gives existence meaning? The answer may have less to do with the future than with the quiet night surrounding us right now. Imagine walking through a museum just after closing time. The visitors have gone home. The conversations have faded. Only the paintings remain, resting quietly beneath gentle lights. The artworks have not changed, simply because no one is looking at them. Yet the experience feels profoundly different. The building has become almost entirely silent. The distant future of the universe invites a similar question. If one day there are no observers left, what becomes of beauty, history, and existence itself? Human beings naturally connect meaning with awareness. A song feels complete because someone hears it. A story lives because someone remembers it. A sunrise seems precious because someone quietly pauses to watch the colors spread across the horizon. It is easy to wonder whether these moments still matter when no witness remains. Astronomy cannot answer that question. Neither can physics. The equations describe motion. They describe gravity. They describe energy. Meaning belongs to another conversation. Still, science gently shapes the way we approach it. For billions of years before life appeared on Earth, stars quietly formed, burned, and disappeared without human eyes to admire them. Galaxies collided across magnificent distances. Nebulae blossomed into brilliant colors. Black holes quietly gathered matter. None of these events waited for observers before unfolding. Nature simply continued its patient work. Imagine an old forest untouched by human footsteps. Trees continue growing. Rivers continue flowing. Autumn still paints every leaf with quiet shades of gold and crimson. The forest does not require applause to become beautiful. Beauty seems capable of existing before anyone notices it. Perhaps the universe shares that quiet independence, or perhaps beauty reaches completion only through experience. Philosophers have debated questions like these for centuries. There may never be one final answer. That uncertainty is not a weakness. It is part of the wonder. Think about an unopened letter resting inside a drawer. The words already exist. The paper quietly preserves every sentence. Yet, the emotional experience remains incomplete until someone finally unfolds the page and begins reading. Does meaning belong to the ink alone, or to the meeting between the writer and the reader? The universe gently presents a similar mystery. If conscious beings continue surviving into the far future, then someone may still witness the final chapters of cosmic history. They may observe ancient black dwarfs drifting through darkness. They may preserve memories of stars that vanished trillions of years earlier. They may quietly wonder about civilizations even older than themselves. If no observers remain, the story becomes different, not necessarily smaller, simply quieter. The rivers of gravity continue flowing. Quantum fields continue fluctuating. Space continues expanding. Nature asks for no audience. This thought can feel strangely comforting. Much of modern life encourages constant attention. We measure popularity through numbers, success through visibility, importance through recognition. The cosmos quietly offers another perspective. Most of its greatest achievements unfolded in perfect silence. The first stars illuminated empty space. Heavy elements formed long before any living creature admired them. Entire galaxies matured without celebration. Perhaps value does not always depend upon being noticed. Perhaps existence itself carries quiet dignity. Imagine planting a tree whose shade you will never personally enjoy. Future generations may rest beneath its branches. Birds may build nests there. Children not yet born may climb its trunk. The act remains meaningful even without immediate reward. The universe often seems to operate with that same patient generosity. Every generation of stars prepared the ingredients for later worlds. Earlier cosmic ages quietly served those that followed. Your own body carries this remarkable history. The calcium inside your bones formed inside ancient stars. The oxygen you breathe emerged from stellar furnaces long before Earth existed. The iron flowing through your blood was forged during violent stellar deaths billions of years ago. In a very real sense, the universe spent unimaginable ages preparing the possibility that one evening, someone would quietly lie beneath a blanket and wonder about its future. That realization gently reverses our perspective. We often imagine ourselves looking outward toward the stars, yet the stars also live within us. Their history continues through every heartbeat. Perhaps that is why contemplating the end of the universe feels unexpectedly personal. It is not merely a distant scientific question. It is the final chapter of the same story that eventually produced oceans, forests, music, memory, and consciousness. The philosopher Carl Sagan once described humanity as a way for the cosmos to know itself, whether one interprets that poetically or scientifically. The idea carries quiet resonance. Conscious beings allow the universe to reflect upon its own history. Every telescope, every question, every quiet evening spent beneath the night sky becomes part of that reflection. Imagine a vast library capable of reading one of its own books. The library changes very little, yet something extraordinary has happened. Knowledge has become aware of itself. Life may represent a similar transformation. The universe produced atoms. Atoms formed stars. Stars created planets. Planets eventually supported minds capable of wondering how the story might end. There is gentle symmetry in that journey. The beginning eventually learns to ask about the ending. Whether that questioning continues forever remains unknown. Perhaps countless civilizations survive. Perhaps humanity is only one brief voice among many. Perhaps consciousness itself becomes increasingly rare as the universe ages. Science remains beautifully honest here. We simply do not know. Yet uncertainty has accompanied every stage of our journey. We did not know where the first stars would form. We still seek to understand dark energy. We continue searching for the deepest nature of matter. Wonder has always traveled beside incomplete knowledge. Perhaps it always will. As our journey approaches its final destination, one question quietly remains. If meaning is not guaranteed by eternity, if beauty does not require permanence, if even the stars eventually fade, then what does time itself ultimately reveal about existence? To answer that, we must return to the oldest companion guiding every chapter of our story: entropy, the quiet current flowing beneath every sunrise, every civilization, and every fading star. Place a freshly brewed cup of tea on a table. At first, delicate steam rises into the air. The cup feels wonderfully warm between your hands. Leave it untouched for an hour. The steam disappears. The warmth quietly slips into the surrounding room. Nothing mysterious happened. Heat simply flowed from a place of greater concentration toward a place of lesser concentration. This simple experience, repeated countless times throughout daily life, reveals one of the deepest principles governing the entire universe. Physicists call it entropy. The word often sounds intimidating. The idea itself is surprisingly gentle. Entropy measures the tendency for energy to spread out. Ordered arrangements gradually become less ordered. Differences slowly become more even. A warm cup cools because heat naturally disperses into cooler surroundings. The process unfolds so reliably that we build our expectations of time around it. Imagine watching a movie of ice melting into water. You immediately recognize the correct direction of time. Now imagine the film played backward. Water spontaneously gathers itself into a perfect ice cube, resting on a warm table. The scene feels impossible, not because the laws of physics completely forbid individual molecules from moving that way, but because the odds become unimaginably tiny. Entropy quietly gives time its familiar direction. The stars themselves exist because of temporary differences. Dense clouds collapse. Gravity creates concentrated regions of heat. Fusion begins. Light spreads into surrounding darkness. Eventually, those differences fade. Heat escapes. Fuel disappears. The star settles toward equilibrium. Every chapter of cosmic history quietly follows this same rhythm: difference, transformation, balance. then stillness. The future we have explored tonight is not driven by malice, nor by destruction. It is guided by this extraordinarily patient tendency for energy to become more evenly distributed across the cosmos. Imagine a drop of blue ink. Blue ink falling into a clear glass of water. At first, the color remains concentrated. Slowly, delicate swirls appear. A few moments later, the entire glass becomes uniformly blue. No invisible hand stirred it. The molecules simply wandered according to ordinary physical laws. Entropy works with similar quiet persistence across every scale of existence. The universe began remarkably smooth, yet tiny differences eventually created galaxies, stars, planets, and life. Those structures were never violations of entropy. They were temporary islands made possible because energy still flowed through the young cosmos. As those flows gradually weaken, complexity becomes increasingly difficult to sustain. Think of a water wheel beside a river. As long as water continues flowing, the wheel turns, the mill grinds grain, useful work continues. When the river finally dries, the wheel does not break dramatically. It simply stops. Stars are cosmic water wheels. They transform flowing energy into light, warmth, and the chemical ingredients necessary for planets and life. When the flow finally ends, the structures built upon it gradually become quiet. This perspective changes the meaning of endings. The universe is not failing. It is completing a process that began with its earliest moments. Every sunrise, every forest, every civilization, every conversation, all became possible because differences in energy still existed. Entropy patiently spends those differences, not wastefully, simply inevitably. Nature never appears hurried. That calm inevitability can feel unsettling at first. Yet there is another way to understand it. Imagine listening to a beautiful piece of music. The final note eventually arrives. Silence follows. Would the music become more meaningful if it continued forever? Perhaps not. Endless repetition might slowly erase the very beauty created by beginning, development, and conclusion. Finite stories often carry emotional depth precisely because they unfold through time rather than outside it. The same may be true of the cosmos. Stars matter because they shine for a while. Spring matters because winter eventually returns. Childhood matters because it gently becomes adulthood. Moments gain texture through change. Entropy quietly provides that texture. It allows stories to exist instead of remaining permanently frozen. There is another remarkable thought. Every living creature continuously resists entropy in small ways. Your body repairs cells. Plants gather sunlight. Animals search for food. Entire ecosystems organize themselves using incoming energy from nearby stars. And life does not defeat entropy. It briefly creates local pockets of order while the larger universe continues its broader journey. In that sense, every heartbeat becomes a quiet act of participation, not rebellion. Participation. Life borrows energy, shapes it into memories, relationships, article, curiosity, then gently returns it to the larger cosmos. Imagine children building intricate sandcastles along a beach. Eventually, the tide arrives. The castles disappear. Yet no one concludes the afternoon lacked meaning because the waves returned. The joy belonged to the creation itself. The temporary form mattered while it existed. The universe may invite us to see galaxies, stars, civilizations, and even ourselves through a similar lens. Temporary does not mean insignificant. Brief does not mean meaningless. Fragile does not mean unworthy. These quiet truths become easier to recognize after traveling mentally across trillions upon trillions of years. Against such enormous scales, every human life appears astonishingly small. Yet scale alone never determines value. A single note can transform an entire melody. One sentence can change a life. One evening spent looking thoughtfully toward the stars can quietly reshape the way someone understands existence. Perhaps that is the greatest gift offered by cosmology. It teaches humility without demanding hopelessness. It reveals our smallness while also revealing our extraordinary connection to everything else. The atoms inside us once belonged to ancient stars. The future of those stars eventually becomes part of our own story. Now only one step remains. We have followed the universe almost to its final whisper. We have watched the stars fade, the galaxies separate, black holes patiently evaporate, entropy smooth every remaining difference. There is only one place left to return. The quiet room where our journey first began. The lamp, the window, the gentle night surrounding you now. Only there can the story of the last star finally reveal what it has been trying to tell us all along. Tonight began with a simple gesture, a hand reaching toward a light switch, a quiet room preparing for sleep. Nothing about that ordinary moment suggested we were about to travel farther than any spacecraft could ever journey. Yet, here we are, having crossed billions, then trillions, then numbers so immense they quietly escaped the limits of imagination. We followed the last star almost to its final breath. Now it is time to come home. Look around the room where you are resting. Perhaps a small light still glows somewhere. Perhaps the only illumination comes from the screen before you. Perhaps the room is already wrapped in gentle darkness. Whatever surrounds you now belongs to an extraordinarily rare moment in cosmic history. Outside your window, our sun continues quietly transforming hydrogen into light. It has done so for billions of years. Tomorrow morning, without asking anything in return, it will warm oceans, forests, mountains, cities, birds, trees, and every sleeping person who eventually opens their eyes beneath its familiar glow. It is easy to believe such mornings are ordinary. They are not. They are astonishingly precious. The universe has already shown us why. Stars are temporary. Galaxies are temporary. Even black holes appear temporary. Yet tonight, countless living stars still decorate the sky. The Milky Way still stretches above quiet deserts and dark oceans. New stars continue forming inside distant clouds of hydrogen. The great cosmic library has not yet closed its doors. We are reading while the pages remain open. That realization changes something subtle inside the mind. Before this journey, the night sky may have appeared distant, cold, almost indifferent. Now it feels different. Those tiny lights become elderly travelers carrying stories billions of years old. Every photon arriving tonight completed an extraordinary voyage simply to reach your eyes. Across unimaginable distances, ancient stars quietly greeted this single evening of your life. There is gentle beauty in that meeting. You did not travel to them. They traveled to you. Imagine receiving a handwritten letter mailed many generations ago. The person who wrote it never knew your name. They never imagined the room where you would one day unfold the page. Yet somehow, their words still arrive. Starlight feels remarkably similar. Ancient nuclear fires prepared these quiet messages long before humanity existed. Tonight, they finally reach another curious observer beneath the darkness. Perhaps that is enough. Perhaps wonder does not require certainty. Throughout our journey, we encountered many mysteries. Dark energy remains mysterious. The deepest nature of black holes continues inviting questions. Proton decay has never been observed. The ultimate fate of consciousness remains unknown. Science does not fear these uncertainties. It carries them carefully. Like lanterns rather than obstacles, every unanswered question quietly illuminates the next path forward. There is wisdom hidden inside that attitude. Human life often encourages certainty. The cosmos encourages curiosity. One closes doors, the other gently opens them. Think once more about the last star. Its story was never truly about one distant red dwarf surviving across impossible ages. It was about patience, about quiet endurance, about small things accomplishing extraordinary journeys simply because they never hurried. Nature repeats that lesson endlessly. A river shapes stone through persistence. Trees grow ring by ring. Children become adults, one ordinary day at a time. Galaxies evolve through countless tiny changes invisible to individual observers. The last star merely carried that lesson farther than anything else ever could. As strange as it may sound, the end of the universe also teaches something comforting about the present. If nothing lasts forever, then every ordinary moment quietly becomes more valuable. Morning coffee, rain against a window, the voice of someone you love, a walk beneath autumn trees, the warmth of sunlight resting on your face. These experiences do not become meaningful because they resist time. They become meaningful because time gently carries them forward. Imagine hearing the final note of a beautiful symphony. The silence afterward does not erase the music. Instead, it allows every earlier melody to settle peacefully inside memory. The universe may one day experience its own vast silence, yet that silence cannot erase the countless stars that once shone. It cannot erase the galaxies that once danced together. It cannot erase the civilizations that once wondered how everything might end. History remains part of reality simply because it happened. That may be the quietest truth of all. The universe does not ask us to become immortal. It simply offers us the astonishing opportunity to exist at all, against the backdrop of almost 14 billion years. You are here, aware, curious, capable of asking questions that even the stars themselves can never ask. Perhaps consciousness is one of the rarest lights the cosmos has ever produced. Not brighter than a star, not stronger than gravity, but able to appreciate both. Outside, the night continues exactly as it always has. Photons continue crossing empty space. The Earth quietly turns beneath your feet. The moon follows its patient orbit. The sun waits beyond the horizon. Far beyond all of them, ancient galaxies continue drifting through expanding darkness, carrying with them the earliest chapters of existence. And somewhere unimaginably far ahead, beyond every calendar that could ever be written, the last star still waits for its distant evening. Not tonight, not for trillions upon trillions of years. Tonight, it remains only a quiet promise, hidden inside the future. Your own story belongs somewhere much earlier, somewhere warmer, somewhere filled with living sunlight. As your breathing slows and the room grows quieter, perhaps the night sky no longer feels quite so empty. Perhaps every small point of light now seems like an old companion traveling beside you through time. Patient, silent, enduring. And perhaps the greatest comfort is knowing that although the stars themselves will one day fade, the wonder they awakened inside countless minds has already become part of the universe's own long story. So rest peacefully beneath tonight's living sky. It is younger than the one we visited, brighter than the one we imagined, and more precious than we often remember. Good night.